Hello and welcome back to PharmaWise. In this video, we are going to discuss how to prepare different solutions of different normalities. Now, normality is also a method of expressing concentration, and how it is defined. Normality is defined as number of equivalents of that particular substance dissolved in given volume of solution, and this volume of solution is generally referred or given in liters. So number of equivalents in given volume of solution gives you the normality. Now in the last video we discussed how to prepare various molar concentrations. In this video we are going to see how we are going to prepare various normal concentrations using the same formula. See, what I am going to do is I am going to simplify this for you, and I am going to give you a simplified formula where normality is equal to. Now just like molarity, we use number of moles there. Number of moles we calculated by weight upon molecular weight. Here we have to find out number of equivalents, and number of equivalents we are going to find out by taking weight upon equivalent weight. So weight upon equivalent weight gives me number of equivalents, and then there will be volume in liter. So this formula we will be using to calculate the normality. Okay. Now let's take an example. Suppose I have to prepare 1000 ml one normal solution of sodium hydroxide. Now here you know the molecular weight of sodium hydroxide, it is 40 grams, but we are not using molecular weight here, we are using equivalent weight here. So NaOH is a base, and for base equivalent weight can be calculated by the formula molecular weight upon its acidity. Now acidity can be easily put in the form of number of H plus ions neutralized, or you can say number of OH minus ions produced. This is going to be very easy to calculate the acidity of that particular base. So what is the acidity of NaOH? Number of OH minus ions produced by it. It is obviously 1 OH minus ion. So the equivalent weight of NaOH is going to be molecular weight upon 1, and the molecular weight is 40, so equivalent weight is also going to be 40. Now I know that the equivalent weight for sodium hydroxide is 40 grams. Now I have given you the volume, it is 1000 ml. So if I put it like that, normality, I have to prepare one normal concentration, so one normal is equal to weight I need to find out. Equivalent weight I have just figured out, it is 40, and volume 1000 ml is 1 liter. So when I solve this, 40 grams is the answer. So if I dissolve 40 grams of NaOH in 1000 ml, my normality is going to be 1 normal. Now let's take an example for an acid, right? Let's take an example for oxalic acid. Now oxalic acid has formula H2C2O4, and it is a dihydrate 2H2O, whose molecular weight comes to 126 grams. Now look at the structure. When this oxalic acid actually dissociates, it gives away these two protons, resulting in oxalate ion, which is this ion, and 2H plus ions are produced, right? So when I need to calculate the equivalent weight for acid, I will be putting molecular weight upon its basicity, and basicity is nothing but number of H plus ions produced. So that gives us the value of basicity. So here 2 H plus ions are produced. So molecular weight is 126 by 2 comes 63. So 63 grams will be the equivalent weight for oxalic acid. So this is how you are going to first calculate the equivalent weight and then put the values in the same equation. You will be given the normality value, you will be given the volume you are going to prepare, equivalent weight you will calculate. For oxalic acid it comes 63. You know this, you know this, you know this. You can calculate the weight which needs to be dissolved in this volume so that this normality can be achieved. So this is how we are actually finding out the amount of substance which needs to be dissolved for that particular concentration in the given volume of solution. I hope the concept is clear. If it is helpful, don't forget to like the video and share it with your friends. Let's meet in the next video. Till then, take care. Bye bye.